everyone?
It's going live.
It's going live. Okay.
You're live.
Hi, everyone. Just wanted to do a check for the live stream that everyone can hear. If you can comment, Ben will tell me. Audio coming through. Cool. Awesome. All right. We'll get started. It's 10:05. Hi. Welcome to the assignment live stream. Hi to everyone who's in person. Hi to everyone who's live online right now, as well as everyone who's watching the recording. Future you. I'm Catherine. I'm one of the tutors for COMP1511, and I'll be going through the assignment 1 today. So, how this will work is Ben, the lovely Ben, is currently in the comments. So if you do have any questions, you can always pop them in the chat and he can read them out to me. But otherwise, yeah, we'll go through the spec. You can expect me to show you the reference implementation as well, how to get started, and we might actually have a look a bit at the starter code as well, and just do a bit of a walkthrough of everything that you need to know for assignment 1. As well as some of the admin stuff as well, so the marking criteria, the due date, etc., etc., etc. If you have any questions in person, just feel free to pop your hand up whenever. I'll try and have a question section kind of towards the end of every stage that I explain, and in the chat, go for it. Cool. Okay, so before we kind of jump into the meaty part of this spec, I just wanted to go through a bit the high-level overview, which is this assignment is based on a car park management system. So it's called CS Car Park, and it's a management system for your very own car park business. And so if you can see kind of from this first paragraph, it will model all the typical comings and goings you would expect in a car park. So everything from parking cars into car spaces, keeping track of how much you have to pay when you leave. Maybe you want to move your car from different spaces. Maybe you want to figure out how many cars are in your car park. As some of you may have seen in real life, some car parks have that like LED screen on the outside that shows you how many cars are inside that car park. And a bit of, I guess, backstory about why I've written this assignment is, you guys are currently in week 4 of COMP1511, and what's super, super exciting and what I hope you guys can appreciate is that just with 4 weeks of coding experience, you can do something that has real life implications. So some of the stuff that we're doing today, it is definitely simplified to what you will see in real life. But, if you were to ever start a car park booking business where you need to book car spaces on a website, a lot of this stuff is something that carries through and is foundational for how you would make a system like that. So I hope that's exciting to you, that the work that you're doing has real life implications and is very tangibly useful in life. But yeah, so in terms of the assignment structure, as you may have heard from your tutors, the assignment is based on 2D arrays and structs. And so specifically, the car park has been implemented as a 2D array, and every element inside that array is a struct. So the struct itself is called struct car space. So how that works is essentially you have a 2D array, and every single element inside that array is representing a parking space. And so the car park you can think of, if we go down and have a look at the diagram for a second, you can think of it as a grid. So this is a 2D array, and every single element represents a struct, and that struct is essentially holding information to do with the parking space. So if we have a look at this part here, this essentially kind of goes through what is initially in this given struct. So what's great is that we've given you some starter code to start with, which I'll go through in a second. And inside that code, we've defined a few things to get you guys started. So the first thing being the struct. So it's called struct car space. It contains a whole bunch of stuff. The first one being an enum. So this enum, essentially, it's called type, and it defines the type of parking space. And we'll look in a second at that definition as well. So different types of parking spaces, as you may have seen in real life as well. There's also an integer, which is a parking rate. So this is the rate that is associated with that particular parking space. Again, throughout the spec, you'll see notes throughout that tell you how much a different type of parking space should cost, and we'll go through that in a second as well. We have an int license plate. So if there is a car that is currently being parked in that space, then this is where you would store that license plate of that car. The license plates are 4-digit integers. You can always assume that they're going to be 4-digit integers as well. And if there is no car at that parking space, then you can assume that has a value of empty, and this value has been hash defined in the starter code as well. And then we also have an int occupied since. So this is representing a time variable. So this is a time at which the current car entered the current parking space. And so this might be useful to you as we kind of go through the stages and we have to start thinking about calculating the parking fee for this car. So we need to know, when did the car enter this current parking space, so that when the car leaves this parking space, we can figure out how much it should pay for its stay. Again, this has the value of empty if there's no current car in that space. I mentioned time, so an important note on time is that time in the assignment, whoops, that is not what I wanted to do. Okay, important note on time. So time in the assignment is representing hourly numbers. So we're only going to have time values between 0 and 23 inclusive. So that's something that you can assume is just representing hourly values. So if a car parks in a space at time 0 and it leaves at time 3, then the car was parked for a total of 3 hours. You can also assume that all the commands that you get, so any times that are typed in by the user input, will always be given in chronological time order. So that's something that you can always assume. I mentioned the enum earlier. So enum representing all the possible values for different space types. So there are different car space types. The first one being normal. So the normal car space is just a typical car space. It has a parking rate of $10 an hour, and it's denoted by the letter N on the printed car park. Premium car space that has a parking rate of $50 an hour. It's basically the same as a normal parking space except more expensive, hence the word premium, and it's denoted by the letter P on the printed car park. And then as you kind of go through later stages, so in stage 3, you're going to start seeing car wash bays. So these are essentially built on a car space, and a car can park inside that car wash bay, and using that car wash comes with a price as well. This one's a little bit different, so it's not an hourly rate, it's a $15 per use, so it's a one-time cost. If a car parks in a car wash for multiple hours, it will only be charged $15 flat rate. It's denoted by the letter W on the printed car park, and I'll show you the printed car park in a second as well. And then we also have, in stage 3, an electric charging station. So this is, again, built on a single car space. Cars cannot park on top of a charging station, and the charger costs $7 per hour to use, and they are denoted by charger on the printed car park. Does anyone have any questions up to this point, either in chat or in person? Awesome. Sorry, yeah.
Just with the electric charging station,
Yep.
They can't park on the charging station, so they have to park next to it. So what's the parking?
Yeah, that's a good question. So for the people online, the question is, if we can't park on a charging station, do they have to park next to it? That's a really great question. You'll see in stage 3, electric charging stations, when you build them, they're associated with a cable length. So every charging station has one cable. If it has a longer cable, then it has a greater radius. So I'll show you that diagram in a second, but that's a really good question. So cars can't park on charging stations. It depends on kind of how close a car is parked to a charging station. It may be able to be charged. Cool, great question. Okay, so in case a lot of that is going over your head, what's been wonderful is that we have provided a interactive model that you guys are all welcome to play around with. This is the diagram that I showed you earlier. This just represents our car park. What I haven't mentioned yet is the dimension of our car park. So our car park has 8 rows and 6 columns. So 8 rows and 6 columns. So these are hash defined already in our starter code as car park rows and car park columns. And this means that we have a 2D array of struct car spaces. We have 48 car spaces. So if we scroll down a little bit, we also have an interactive model. I will just zoom out a little bit to get this in frame. Please, I encourage you to have a play around with this. Essentially, you can toggle these index values and this will change the highlighted car space in the grid. So if I were to pick 1, 3, that will represent this car space here. So it's a 2D array. This is how we access the different elements inside that array. So remember, we go row first and then column. So this is the struct car space that we are referencing here. And also you can have a play around with the different struct field values as well. So inside our struct, as I mentioned earlier, we have 4 different field values. We have space. We can also look at parking rate. So this is a normal car space that has a parking rate of 10. Currently, all of these spaces are empty. So this interactive should correspond to this diagram here. So if we have a look at this diagram, this row here, the 3rd row, is associated with our premium parking. So if we have a look then at, let's pick a spot in our 3rd row, what does that look like? That's not it. Let's try a different one. We have a premium car space here, and it has a parking rate of 50. Again, it's empty currently. So have a play around with this. It should help you get familiar with, I guess, a mental model of what the array should look like. And you can always have a look at these diagrams. So these diagrams are sprinkled throughout as well to help with your understanding. Cool. Okay. Last thing at the bottom here, just a note that the indices indicate which struct in the array that you're accessing. Let me just zoom in a little bit again. Wrong way. And the word after the dot indicates which member of the struct that you are accessing. So this is just referencing this line here. These indices represent the struct that you're accessing. This word here represents what field inside that struct you're trying to access. And the very last thing is that each car space you'll see throughout the spec is referred to in the following format. So it goes row first and then column, and it's just in parentheses. So for example, car space 00, that is just referencing the one in the top left-hand corner, this one over here. Cool. Any questions so far? All good? Lovely. Okay. So I have mentioned the starter code a little bit, so maybe I will go through, and at the very end, if we have time, I'll go through all of these steps to actually help everyone get started. But for now, I will just open the starter code over here and zoom in. Cool. So different ways you can download the starter code. This is just on the web. This is really great because we provided you some code to start out with, and we also provided you some things that have already been defined, some functions that have already been defined. So please have a read of the starter code before you get started, because you might run the risk of starting to write a function and realizing we've provided some functionality already. So let's go through this in a bit of detail. So as I mentioned before, we've provided you some constants already, including the car park dimensions. We've also provided you the normal parking rate, which I mentioned was $10 an hour. We've also hash defined a value for empty as well. You can add as many hash defines as you would like, and I would definitely encourage you to hash define any constants that you add to your code. Then we have our enum that I went through earlier. So this is, again, the different space types, and we have the struct that I mentioned earlier. You can add more enums if you wish. You can add more structs if you wish. You can also edit this struct as well. You may see that in later stages, you may want to add some members to the struct. That's totally okay as well. And definitely recommend that you also write your own function. So there's a spot here for you to add any function prototypes for functions that you write. Here are some provided functions as well. I'll go through these in a second. So the provided functions are at the bottom. You can have a read of the function comments at the top that will essentially take you through what each function actually does, but I'll go through that now as well. So this is a function called initialize car park. So it just takes in a struct car park. Remember, this is a 2D array of structs, and initializes car park spaces as normal spaces with normal parking rate. So initially, our car park at the very beginning, all of them are normal spaces with a normal parking rate, and they are all empty spaces. We also have given you a function called print car park. So this takes in, again, the car park, and it will essentially do some formatting and print out the car park for you. And it calls this function print car space, which does all the formatting that I mentioned. So normal is denoted by N, premium denoted by P, etc., etc. So if I just jump to the spec quickly and find an example of printing the car park map, if I expand this example, so this is an example of what the car park map looks like printed. So the functionality for this has been implemented already, so you don't have to worry about figuring out how to format this or anything like that. You just have to call this function print car park. Cool. In terms of what else has been given in the starter code, this is the main function. So inside the main function, we initially just set up the car park. So we're just declaring our 2D array, and then we're going to call that initialize car park function, and that will initialize all the car spaces to normal and empty. And then this is where you start writing your code. So stage 1, we've given you some print statements, and then this is where kind of you can get started with actually setting up the car park, and this is the logical place where I go back to the spec and go through stage 1. Does anyone have any questions about the starter code? Awesome. Okay. So stage 1.1, car park setup. So initially we just want to set up a few things, and the very first thing that we want to set up is, once we've initialized our car park, which is already given in the starter code, we want to figure out how to get user input to essentially reserve one row of our car park to be premium car spaces. So in every car park, we will have one single row that is reserved for premium car spaces, and your job is to take input from the user, asking them where they would like to place the row. The car park should then be printed once after that premium parking is reserved using the provided print car park function. So you're expected to print out, welcome to CS car park, which row of the car park would you like to reserve for premium parking, and then take in some user input. So if the user types in the row number of 3, then you can see on this diagram, essentially, we want to make sure that row turns into premium parking. So in every stage, we will have different subheadings. So we'll have kind of a description section, which just tells you what we expect you to do in this stage. And then we'll have a section called assumptions, restrictions, and clarifications. So this is just a few things that we are essentially just letting you know that we won't test particular things. So for example, row number will always be a valid row. What that means is that it will never be out of bounds. So you personally won't need to check that it is out of bounds. The first row of the car park column, the first row of the car park has a row number of 0. So remember that in arrays, everything starts in cases have a higher parking rate associated with it, which is $50 an hour. And here's a bit of a hint on how you would get started with stage 1.1. We'll probably maybe go through a tiny bit when we actually go through our demo of getting started, when we actually do a bit of code. In every stage section as well, you'll get an example section. So this is probably going to be the most useful section to you, and it will essentially show you some example input and what the expected output is. So user input is going to be bolded, so you can see that the number 3 here is what the user types in. That's going to be bolded, and then everything else is the output that you expect. So once you type in the number 3, press enter, then the expectation is that you will print out the car park map again, and when that's printed out, you can see that that third row here has now changed into premium parking spaces. At the bottom as well, of every stage, you can run a command which auto-tests the code that you've written, and this is particular to this section. So instead of, I guess, what you're probably used to with the labs where you kind of auto-test everything at once, this will just auto-test for this particular section. Cool. Does anyone have any questions so far? Yes?
So the maps will constantly be updated if some pieces were taken and then like that.
Yeah, that's a good question. So the question is the map going to be constantly updated when you kind of change things around in the car park? So let's have a look back at the starter code and see how that print function actually works. So this print car park, essentially, if you pass it the 2D array car park, it will essentially just loop through that car park and print the spaces. So essentially what you need to worry about kind of in stage 1 is as long as you ensure that you update this car park array, then the print car park will just take that latest version of the car park and print out and form everything properly. Does that make sense?
So we're changing the struct,
Yes.
and then it'll be updated automatically.
Yes.
Is that correct?
So long as you change the struct, and then after you change the struct, you run print, you call print car park, and you pass it that car park array which you just changed, then print car park will go through that latest version of the car park. Good question. Online. Awesome. Okay, cool. So let's now move to stage 2. So once we've done that initial setup, we're ready to add some initial cars to be added to the car park. So the user will input the number of cars that will be initially parked in the car park, and then you will need to scan in a license plate and a row and column in which to place that car. So what that looks like is you should print out a prompt that says, add all current cars to the car park. How many cars would you like to add? Scan in the number of cars, and then for each car, the user will input a line, and that line will go license plate number, row, and then column. Once all of those cars are placed, you should print the car park again, followed by the message, the car park is now ready for business. There's some error handling to be handled here. So if the row or column entered by the user is outside the bounds of the car park, for example, if they enter negative indices, then you should print the error message invalid car space. So as we kind of go along the stages, you'll notice more and more error handling that we expect you to do. Let's have a look at the assumptions as well. So license plate number, we can assume, is going to be unique for all the initial cars that are typed in at this stage. So you don't need to check for any duplicates. You can assume that that license plate number is always going to be a 4-digit number. Initial cars all have a time of entry of 0. That's why they're called initial cars. You'll also always be given the correct number of inputs. So if the user specifies 3 cars, you will always expect here 3 rows of input. Number of cars will always be greater than 0, so you don't have to worry, 0 or greater, so inclusive, so you don't have to worry about any negative numbers being typed in at that stage. And then any invalid cars are ignored, and you can assume that no 2 cars will be parked on the same space, at least in this stage. So again, if that is a lot of words, always I would recommend taking a look at the example, because that illustrates what is expected of you in terms of output. So in this particular case, we've done our setup for stage 1.1. So premium parking is our row 1, and then you need to print out add all current cars. How many cars would you like to add? And the user in this case wants 2, so you type in 2 rows, and then when you print out the car park again, we can see that now our car spaces, so this is car space 11, it's now been filled with a car with license plate 1111. And then we also have another one parked in the location 55. And at the very end, you want to print the car park is now ready for business. And we also have another example for that out of bounds case. So if you were to type in the row and column 88, that's beyond the bounds of our car park, then you will print the error message invalid car space. Cool. Any questions so far with stage 1.2? Yes.
So the one you mentioned about 2 cars parking in the same spot, is it like when they input the same number, the same parking lot? We don't need to put an if statement saying you cannot do that.
Yeah, exactly. So you the question was referencing the clarification, which is you can assume that no 2 cars will be parked on the same space in this stage. That's exactly correct. So you will not get a situation where I give you 1 1 1 1 1 1 and then 2 2 2 2 and I also place it at 1 1. So that's not something you need to check for this stage. Great, awesome. Moving on. So that's pretty much all of the setup done for stage 1. Now things get super fun. So stage 1.3, printing the car park map. From this stage onwards, the car park is ready for business. So this means that the user commands are now to be read in a loop. So this loop will continue until the user presses Control D on the keyboard. So if some of you have had your tute already, you would have hopefully been familiar with this idea of looping until Control D, but you'll definitely see it this week. So this is known as a command loop, and so it looks something like this. Once you print out the car park is now ready for business, you should print out enter a command, and some commands, and we'll look at what commands are in a second, will be typed in. Whatever associated action is executed according to that command, and then you essentially loop and continue printing out enter a command, and that could happen multiple times until the user types in Control D, at which point the program should print the goodbye message, which is the car park is now closed, bye. So the question is, what are commands? So commands in this particular case are going to be represented by characters. So in this stage, we want to print the car park map. So the command is the capital P. So if the user types in the capital P after the enter a command, then essentially we want you to print the car park map. So this stage is focused on providing the ability to visualize the car park map. So when the P command is executed, your program should call the provided print car park function. So this is the same function that you've been using in stage 1.1 and 1.2. Here are a bunch of notes. So remember that when you are scanning in characters, to remember to put a space in front of that %C in your scanf. And here's also a note on how you can stop your command loop. And this is a reminder to use functions. So every stage after including stage 1.3 will require the command loop. So it's a good idea to separate each command into their own function. So that's definitely a good tip. I definitely recommend you to try and use functions from this stage onwards. Here's another note. Functions are extremely important for this stage onwards. Cool. So what does that actually look like in the example? So we've done our setup. We've added our 2 cars into our map. And now our car park is ready for business. We have enter a command, we type in capital P, and all that does is it calls that same print function again, and then prints the car park, and then notice that enter command is now prompted again, and then the user presses Control D. That's when the bye message is printed. Any questions so far? Lovely. Okay, so stage 1.4. This is when we're going to be parking cars now, which is, I guess, the whole point of a car park. And so this command is a bit more complicated than the previous one. This one now takes in a whole bunch of variables after our command. So the command for parking cars is denoted by the lowercase p, and then you're also expected to type in 4 values after that. So a license plate number, a row, a column, and the time of entry. So what this means now is it's similar to when we were placing our initial cars, but this time, in addition to giving the license plate and the location, we also want to give the time of entry. So we can no longer assume that these cars have entered the car park at time 0. So this time of entry can be anything from 0 to 23. Remember that times are going to be given chronologically, so you won't have a situation where you're expected to add a car at time 3 and then add a car at time 1. It will always go 1 and then 3 if you wanted to place those 2 cars. Cool. So that's essentially everything that I've said here. Remember that, like the print command, this parking command should also be implemented in the command loop. And if successful added, you'll print this following message. Some more error handling. So again, you need to handle the out of bounds error. And you also now need to handle the situation where if you're asked to add a car to a car space that already has another car in it, now you have to deal with it. So this is the error message that you'll need to print out. Again, assumptions that you can read, I think I've mentioned all of these as well. Errors will be checked in the order that they are outlined above. So if both of these are true for some reason, only the first one will be printed, and then you should end the program at that stage. Okay, so here's some hints that you can read as well in your own time. And here's just an example of what that looks like when you're parking. So again, setup, car park is ready for business. We type in our command P followed by license plate, row, column. So we're going to be adding to position 44 and then also at time 1. So this is what you should print out directly afterwards. And then notice that in our command loop, when we now print out our car park map, we can have a look and see our car 2222 has indeed been placed into position 44. And then again, we can end the command loop afterwards. And you can have a look at the error examples as well. But that's stage 1.4. Any questions so far? Sweet, let's move on. Total occupancy. So command here is O. So as I mentioned before, sometimes there's a sign at the front of a car park that tells you how full that car park is. This is exactly what we want to implement in this stage. So you would want to count how many total cars are currently parked in the car park, as well as how many empty spaces are remaining, and then print that out. So what that looks like with examples is I've just added a bunch of cars, I've parked in 4 cars, and then when I give the command O, it says there are currently 4 cars and 44 empty car spaces in the car park. So that's kind of the functionality that we're expecting from this stage. And that is stage 1 done. So you'll notice that every stage is kind of split into smaller parts. Stage 1 has 5 parts, stage 2 has 4, stage 3 also has 4, and stage 4 has 2. At the end of every stage, you get to this section. Remember to run 1511 style. So that's, I think, something I'd recommend you do after every stage so you can keep up with ensuring that your style is okay. That will save you time at the very end. And then you can auto test. So this is the auto test command for all of stage 1. And then also this is the give command. So similar to how you've been submitting your lab exercises, this is how you would give your assignment. I would recommend submit early and submit often. So it says give early and give often. Only your last submission counts. So you can submit something that's not yet ready, but submit it. That way we have a record of it in our auto test history. So if something goes wrong, your laptop corrupts itself, or like, I don't know, drops into a river accidentally, then we have hopefully a copy of your code in our auto test history and in our submissions. So I definitely recommend you submit often. And if you submit again, that second last submission will essentially be, we won't look at that. Cool. Okay, so stage 2, as we kind of move on to additional stages, I'll go through things in a bit less detail. So stage 2 is free spaces remaining. So the command is capital F. So this is for the situation where you have a almost full car park and you can't find parking. Wouldn't life be much easier if you know which spaces are free? So this is the functionality that you're going to be implementing this stage. So you should print the free spaces and the parking rate associated with those spaces in this following format. So all the normal spaces followed by all the premium spaces, and they will be in ascending order of row number and then column number. If we have a look at what that looks like. So I've added a bunch of cars into the car park in a nice diagonal fashion. And then when I press that free spaces remaining command, this will give you a list of all the free spaces that are remaining. So hopefully we can see kind of the real life implications here, which is this could potentially be something that they use if anyone has ever been in a car park where they have kind of the red lights and the green lights above every parking space. This is something that can be helpful for a car park manager to identify which spaces are still free. In stage 2.2, this is when we start actually changing prices around a little bit. So since you are a business owner, then you want to encourage as many customers to park in your car park. So if you have a lot of empty spaces, you may want to discount them so that more people are likely to come in and use your car park. So in this stage, you'll be implementing a command which applies a discount of 10% to the parking rate of all empty spaces inside the car park. And once a discount is applied, you'll print this message here, and only empty spaces get an applied discount. You can apply this discount multiple times, as we'll see in the examples. And here's some information about rounding as well. So have a look at what this looks like. So again, same kind of example here with our diagonals. We're going to print our free spaces. All our normal spaces have a $10 rate so far, and premium spaces have 50. And then we add a discount, and then we check our free spaces again, and notice that they have now been discounted to $9 and our premium space to $45. And you can have a look at the second example as well, which essentially runs that discount multiple times, and you should see the number continue to go down. Cool. Stage 2.3 is find a car. So this is a situation where sometimes you're in a big car park, there's 48 spaces, you forget where you parked your car. So this is a situation where you type in the command lowercase f followed by the license plate number of a car that you're looking for. If the car is found, this is the message that you want to print. But sometimes you now have to handle the error of if the user inputs a license plate number that doesn't match any of the license plate numbers of the car inside the parking lot, in which case a different message is printed, so no car could be found. Again, you can have a look at the examples here. And then stage 2.4, which is leaving the car park. So leaving the car park is fun because it's kind of a two-part process. Not only do you have to remove the car from the car park array, you also have to ensure that you calculate the parking fee associated with the car's stay. So if the specified car successfully leaves the car park, the car parking space should return to its original state. So it should be empty once again, and the parking rate should return to the original non-discounted rate. And if it successfully leaves, this is the message that you want to print. Notice that you need to calculate how long it was in the car park for, as well as the total price for the duration of its stay. Some error handling again. So if you enter a license plate number that again does not match, then the following error message should be printed. Notice that this is very similar to what we saw in the last stage. So maybe that's something you want to put into a function, for example. There's also a situation that if the time of exit provided is before the car's entry time, then you'll need to print the error message that the time of exit provided is invalid. A bunch of assumptions as always, and clarifications as well, again, that you can read in your own time. I will also mention at this point that if there are any edge cases that you aren't certain on, you can always ask in the forum for extra clarification. Was that a question at the back? Okay, cool. Awesome. So examples for leaving the car park, I'll just show you one briefly. So we've parked the car and now we want car 1111 to leave at time 3. So it was parked for 3 hours, total price is $30. And then when we print the car park map again, 1111 is no longer in the car park. And then we can also get number 2 to leave. Notice that number 2 was parked in a premium space, and so it has a price of $350. And then we print again, and now the car park is empty. Cool. Any questions for stage 2?
Not stage 2 specific, but someone's wondering, is the assignment marked purely by auto test like labs, or does the tutor read through parts of the code and check it?
That is a very good question. We'll probably talk through that in greater detail at the end when we go through the marking criteria. But in short, style will be manually marked by tutors. It will be similar in that the, functionality will be marked using auto tests. However, we may also add on some extra marking tests that you won't be able to see in addition to those auto tests. Good question. Any other questions in the room? Okay, cool. All right, so stage 3 and stage 4, this is when things get more exciting. So stage 3, again, I'll go through in less and less detail, but just for you guys to be aware of what is coming up. You can build electric charging stations. So when you build these, you specify when you build them, the row and the column, and this is where we bring in the idea of the cable length. So how does the cable length work? Let's have a look at actually charging cars. Whoops. Okay, so charging cars have its own command given by C, license plate number of the car that you want to charge, as well as charging from and charging till. So these are time values. Page 3.1, every charging station has one charging cable. That means only one car can be connected to a given station at a time. And the distance of a car from a given charging station can be calculated using the distance formula. And so what this looks like diagrammatically is if you have a charger with a charging cable of length 2, then only cars parked in these green spaces are eligible for charging with this charger, because those are the only ones within the given radius as calculated by the distance formula. Does that answer your question? Perfect. Okay, so a few more examples. This is with cable length of 3. And again, similar to every other stage, you have a bunch of things to error check and a bunch of assumptions that you can read through as well. And then, as always, we have examples. So you can see in stage 3, things get a little bit more complicated because there are more examples and more edge cases to consider. In stage 3.3, this is when we start to move a car from space to space. So if you have a car that's only in one space and you want to move it into a different space, this is the command that you will use. And you have to specify new row and new column as well as when you move. A bunch of things to consider here. I think the one thing that I will highlight here that might be a little bit difficult is you now need to keep track of how best to calculate your parking fee. So if you have a situation where a car is parked for 2 hours in a premium space and then it moves into a normal space, we need to figure out how to ensure that we're correctly calculating that parking fee to reflect that stay. So that's 3.3. 3.4, car wash bays. So, building car wash bays are given by this command. So you specify the row and the column and the build time with the W. There's a bunch of instructions for how car wash bays can be built. A car wash bay can only be built on a space that is currently empty and if its surrounding spaces are also empty. So have a look at this diagram here. We can only build this W if all of the spaces surrounding it, so the 8 surrounding spaces, are empty. This is because we don't want any of the water from the car wash to affect any cars that's parked around the car wash bay. So just be aware that this is something that you need to check. There's also some information as well about whether cars can park next to a car wash bay as well. So cars should refrain from being parked or moved into surrounding spaces of a car wash bay. If there are no other remaining parking spaces left in the car park, then the car park can be parked or moved adjacent to the car wash. However, this means that this bay cannot be in use anymore. What does in use mean? So a car wash bay can be considered in use immediately after you move a car into that space. So if you park a car or move a car into a car wash bay, it has automatic sensors and then the water will start. And again, to reiterate from before, car wash bays have a $15 per use rate. As always, you can have a look at the examples here. We've also given some diagrams to hopefully make these examples a bit more clear as well. Always welcome to ask on the forum as well. Stage 4 is when things get super fun. So we have parking history. I'll let everyone probably read through this in their own time, but in short, this is just a full parking report for the car, just in case someone wants to dispute their parking fee, or if they just want to know which services they used inside the car park and for how long. This is the stage for that. And for stage 4.2, this is can I exit? So this is now when cars are considered to be able to drive around inside the car park, and if they can only leave if they find a path to the exit without being blocked. So for example, this is an unblocked exit. So the exit is over here. Notice that it can find a path to the exit. This is a blocked exit because it cannot find a path to the exit. So that's hopefully super fun. It's kind of like solving mazes. Again, examples to follow as well. Just to note as well, the auto tests kind of in stage 1 and stage 2 are pretty comprehensive. As they kind of get onto the later stages, especially 4.1, 4.2, we definitely encourage you to do your own testing as well. Any questions about anything from stage 1 to 4? Yes.
Is everything we need being taught in the first 4 weeks?
I think there might be a lecture or two to go, I believe.
Here it's all being taught.
Yeah.
Is my understanding. But
yes.
It either should have been this week or like very early next week. It should be.
Yeah. Definitely in the lectures. In terms of the tutorials, I think next week in our tutorials we'll be going through a lot of 2D arrays and things like that. That is a good note, which is that definitely don't feel like you need to fully master something before you try it in the assignment. So for example, if you've learnt functions and you're like, oh, I feel kind of 30% about functions, I want to understand it fully before I implement it in the assignment, I definitely recommend you just have a go. The assignment is a really good practice ground for you to just get familiar with using things. I think it's very much learned by doing. So I would definitely recommend you have a go and don't feel scared to try something if you aren't fully confident with it. But yeah, good question. Okay, what time is it? 10:50. Let's go through some of the admin real quick, which is, this is how you submit your work. Let me make it bigger again. So this is, as I mentioned before, just like lab exercises, you run the give command, and it will prompt you to say yes a couple of times. Again, submit often, that's my recommendation. Assessment scheme. So in terms of weighting, this assignment is weighted 20% to your final mark. 80% of that mark will be based on the performance of your code. So what that means is 80% of your mark will be based on auto marking tests. So there will be auto tests, and in addition to some of our marking tests as well. 10% of the marks will be given from the automatic style checker that will be run on your code. So this is why I definitely recommend you get familiar with using COMP1511 style. And then also 10% of the mark will come from manual marking, and so tutors will actually go through and manually mark and look at things like your use of functions and how you've named your variable names, etc., etc. And yep, here's that in nice table form. I have had a couple of questions so far about kind of what the expectation is on difficulty for the different stages. So hopefully this table gives you a bit of an understanding. So essentially completing stages 1, 2, and 3 kind of puts you in 85% for performance. So given that your style is good, then that kind of puts you almost kind of at the cusp of a HD. If you finish every stage which exactly follows the spec, then you can expect 100% for performance. But yeah, notice that kind of as the stages go on, they're worth less. So stage 1 has the biggest weighting of 35%. So completing just stage 1 will get you 35%. Completing stage 1 and 2 gets you 65, etc., etc. Style marking rubric. Definitely have a read of this. Essentially, this is the rubric that we will use when we manually mark your work. So indentation, white space, vertical white space, line length, documentation, so that would include comments, function naming, function comments, function usage, function prototypes, over deep nesting, code repetition, constant usage. And if you use any illegal elements, so have a look at the style guide, make sure you don't use any of those illegal elements. If style is something that you're unsure on, definitely I would recommend having a chat with your tutor. They're more than happy to look at your style code, your code, and give you feedback on style, as well as any of these kind of criteria. If you're unsure of what they mean, your tutor will be the best point of contact for that, or the forum as well. Okay, due date. So it's due on the 11th of July at 8 p.m. Something to note as well is the late penalty here. So if you submit past the due date for each day after that time, the maximum mark will be reduced by 5% off the ceiling. So what that means is 1 day past the due date, the maximum mark you can get is 95%, and 3 days past the due date, the maximum mark is 85%. So notice that no submissions will be accepted after 5 days late. Take that information and do with that what you will. You might want to do a bit of math and think about if it comes to it, whether you need to submit a bit later. But definitely I would recommend getting started soon. That would be my recommendation. But yeah, this is pretty much the entire spec. We've got a couple of minutes left. Any questions? Any questions online?
No, all good.
Oh.
Maybe reference quickly.
Yes. So, in the Getting Started tab, this is definitely where I would recommend you get started. I'll do the reference first. So here is the reference solution command. So if you go into your terminal and you type in 1511 CS car park, this will actually run the reference solution. So this is a solution that we've written on our end. You won't be able to see the solution, otherwise the assignment will be much less fun. But essentially, if you have any situation where you've thought about a test case that we haven't illustrated in our examples in the spec, and you're like, oh, what if I park like 3 cars next to each other? And you're like, I don't know what the expected output is. run the reference solution, and this should show you what the expected behavior of your program should look like. So I can type in 3, and look, we've put our premium parking row in row 3, and then I want to add 2 cars, for example, 1, 1, 1, 1, 1, 1, and then, for example, you're like, oh, I wonder what would happen if I put another car in at an invalid car space, so 2 negative indices, and then you can check and it says, oh, invalid car space. So this is what I can expect. My program should also match this implementation. And notice that the 6666 is not added to our car park map. So you can play around with this if you're unsure about anything. So you can print, everything has been implemented. So you can also see car park history as well. So we can get the history for car 1111. Any questions about reference implementation? So that's definitely one way you can get clarification. As always, you can also just ask the forum, and help sessions and past sessions are in full swing, so definitely make use of those, and tutors are more than happy to help you out. Besides that, I can do a quick demo on how we would get started. So here, the suggestion is you make a new directory for your assignment 1, you cd into that directory, so I will just do that now. Let me end this. Oops. Clear. So make a new directory for your assignment 1, cd into that directory, and then there's different ways that you can download the starter code, which I kind of alluded to before. And you can either download it here, or you can run this command, which just fetches. And if we ls now, you can see the starter code has been added. So we can now code cs carpark.c. That should open up VS Code. So this is our starter code, which is great. Make sure you fill in the header comment, I don't want release notes. And essentially you can then go through and get started here. So I probably won't go through this in great detail, but in terms of stage 1.1, how we would get started. So I've added these print statements already. What we would need to do here is now probably scan in the user input. And then once you scan in the user input, you might want to actually change that row in the car park. So remember that our car park is denoted by the word car park. That's the variable name of our 2D array. And then whatever row and column, so maybe you want row 1 and column 2, and then you want that type. Perhaps you want to change that type to premium. So that's how you would change one parking space to type premium. And then maybe you want to print the car park after that. So again, we would run the given function. We'll call that, it's called print car park, and it's expecting a car park as input. So let's do that. Print car park. You'll give it car park. And then we can save that. And then compile DCC car park. CS car park.c. And then we can run car park. I didn't scan anything in. Should probably do that. Actually, no, I'm not going to show you how to scan in. But yes, this is essentially how you get started, and you can see that the car park map did print out because I called print car park. Cool. Does anyone have any last questions? All good online? Cool. Thank you for coming. Thank you for watching the recording. If you're watching the recording, if you have any questions, again, forum, ask in your tutes and labs, go to help sessions. Everyone's here to support you. This assignment is definitely kind of the first real big program that everyone is writing. So we understand that this might not be something that you're comfortable with immediately, and you might not grasp every concept immediately. So just know that everyone's here to support you, and good luck. Thank you.